To very briefly introduce, not the speaker, Professor Capella has the honors of doing that, but to introduce the series. As you know, we've been having Friday noontime colloquia for quite some time here at Annenberg. It predates my own time as dean here. But at the end of last year, we made some changes in the structure of our colloquia to make them, I think, both hopefully more interesting to our attendees, but also more welcoming to our guests. And as part of that, and in honor of Elihu Katz's shift to emeritus status, we have named this new colloquia series the Elihu Katz Colloquium. And I just wanted to mention to everyone here that the structure of the new series is going to be 4 colloquia a semester, 2 by our own standing faculty and 2 by outside guests. We'll be doing that in the fall and in the spring, and these are meant to be school-wide events that we would like all of our faculty, graduate students, and when possible staff to attend as a way of integrating the very different but very important and interesting work that goes on here at the school, and that also goes on in the communication field and related fields to communication. So it's my great pleasure to introduce Professor Capella, who will introduce today's speaker.
It's my great personal pleasure to introduce Professor Noshir Contractor to you and to kick off our series with him. Nosh earned his PhD at the Annenberg School for Communication, not the real one, but the pretender one in Los Angeles, in 1987. He was appointed as an assistant professor at the University of Illinois in 1987, where he moved up in the rank over the next 20 years in the Department of Speech Communication, as well as being affiliated with the UIUC Center for Advanced Study, the National Center for Supercomputing, and the School of Library and Information Sciences, as well as the Department of Psychology at the University of Illinois. In 2007, he moved to Northwestern University, where he is now the Jane S. and William J. White Professor of Behavioral Sciences in the McCormick School of Engineering and Applied Science, the School of Communication, as well as the Kellogg School of Management at Northwestern. He is the director of the Science Networks and Communities program, SONIC, listed up here, research group at Northwestern. These appointments are testimony to the demand that exists for Nosh's expertise across a variety of disciplines, as well as his uncanny ability to hide from almost everyone, each of whom thinks he's busy doing work for somebody else. Professor Contractor is indeed a force of nature. His research program has been funded continuously for almost 2 decades by major grants from the National Science Foundation, with funding from the National Institutes of Health, the Army Research Laboratory, Air Force Research Laboratory, the Army Research Institute, NASA, the Rockefeller Foundation, the Gates Foundation, and the MacArthur Foundation. His book, entitled Theories of Communication Networks, which is co-authored with Professor Peter Manji, who is his advisor at USC and is the godfather of my son, and published by the Oxford University Press. It received the 2003 Book of the Year Award from Organizational Communication Division of the NCA. He's the developer of various computer programs and is a distinguished scholar of the National Communication Association and co-founder and chairman of Syndio Social, which offers organization products and services based on network analytics. His list of awards and honors, invited lectures, currently funded research and publications is really almost overwhelming. I went through the CV beforehand and it killed my morning. In 2013 alone, he's authored 7 published papers in refereed outlets, gave 7 different keynote addresses, and was involved in more than a dozen different grant-funded projects. But in the end, 2013 clearly was an off year, as it appears there were no published book chapters that I could find, and only 1 top paper award. Obviously, he's kind of winding down as he ages, no question. Nosh's overall research investigates factors that lead to the formation, maintenance, and dissolution of dynamically linked social and knowledge networks in a wide variety of contexts. And I'm pleased to say that based on our conversation this morning over his oatmeal and Tabasco sauce breakfast, and no, I am not making this up, that he's beginning to examine, it's the trouble with spending time with friends, that he's beginning to examine the messaging that needs to occur over these networks as a part of the broad process of opinion dynamics that his work is so central to understanding. We are indeed honored and pleased to have Professor Noshir Contractor here to offer the kickoff colloquium for the series named after our esteemed colleague, Elihu Katz. I hope you will join me in welcoming him warmly.
Lots of them up front here.
Check. Is this working? Trying to see how high.
There we go. Hi, Joe.
Hi, I'm Noshir.
You can nosh with nosh right up front. Well, thank you, Joe. It's very humbling and intimidating at the same time to be in this position in front of you today. I've known Elihu and Ruth going back 1984, where I took my first graduate seminar in mass communication at the other Annenberg School, where Elihu was on the faculty at the time. So my first seminar on mass communication actually was with Elihu in 1984, in the spring of 1984. At the time, he was very involved in working in the area of media events with Danielle Diane, and so I witnessed some amazing conversations and amongst them as they were trying to make sense out of those kinds of activities. And then I was then at the real Annenberg School in 1998 as an Annenberg Scholar as part of Elihu Katz's Annenberg Scholars Program. Spent 6 wonderful months here. It was in the fall semester. And that was also the time where I actually began working on the book with Peter Monchi that Joe made reference to, the Theories of Communication Networks. So that book was in essence born at this Annenberg School when we were writing the first draft of it. And then more recently, I had an opportunity to be on a panel at ICA last year in London. And I'm going to start with that because that panel was on looking at network scholarship over the years. And Elihu was at that panel, as was Ron Rice, some of you may know, Richard Rogers, who's in Amsterdam, and I was brought in as the token junior scholar on that panel. And Leah Libro from UCLA was the one who was moderating that session. And as part of the discussion around that, planning for that, I found in my inbox this email that Elihu sent to talk a little bit about what it is that he was planning to talk about at this event. So this was for those of you who didn't make it to the plenary event in ICA in London last year. This was an extract from an email correspondence in preparation for the session that was called the Network Tradition in Communication, Research, and Scholarship. And his email started, it says, so I call it Elihu's Cliff Notes, because this is actually all you really need to know about networks and influence in the field of communication. I could begin, if you like, so this is what he was going to present, by a staccato summary of my arguments that, 1, comm research is all about how things get from here to there. Call it diffusion, in which social networks are central. 2, the problem is common to many disciplines in social science and humanities, from marketing to social movements to history of religion and of art, though they pay only little attention to each other. 3, the problem coincides more or less with what sociologists used to call collective behavior. Fashion, rumor, moral panics, public opinion, etc., but sociology didn't know how to handle these processes, however, and comm may be said to have inherited this area. 4, historically, I would credit Gabriel Tarde, the French social psychologist, as the pioneer whose laws of imitation and studies of conversation are still a foundation. Paul Lazarsfeld two-step flow ideas echo Tarde's theorizing, combining mainstream media with social networks, and Jacob Marino is another pioneer in this area. But only now, with a computer, has it become possible to trace the flow of ideas and things through vast networks and to think big, uppercase, about problems of change. So we have some seniority here, but the competition is stronger, and students of diffusion and social networks sprouting everywhere. Or some such. Regards, Elihu. And I think that it was really, to me, an amazing way of sort of very quickly at a high level capturing and distilling a lot of the reasons why the field of communication continues to be central in the area of looking at social influence and networks. And I was particularly impressed that Elihu continues to recognize also the opportunities that we have today more than ever before in terms of digital trace data. And so part of what I want to talk about today is not about a single research project, but something that I felt pretty passionate about over the last several years, and I think as social scientists and as communication researchers in particular, I would like us to take a more active role, and that is to see how what we do can actually influence and impact our understanding of grand societal challenges. As I sit now in an engineering department as part of my appointment and management schools, one of the things that I am always challenged by and which I hear them say, maybe not necessarily to our face as social scientists, but certainly in the ways they think about it is, okay, so you've given us a lot of insights about what things happen. What can we do with that? How do we make that actionable? And so part of what I want to make the case is that in fact we do things that are very actionable, that have a very influential way of being able to shape a lot of things that go beyond social policies, that actually make beyond, meaning they provide more input into social policy. And I want to talk about 3 examples from our research where we are trying to do that. And I want to make the case that computational social science and network science in particular provide us some very nice tools, both to be able to understand phenomena, but also to enable phenomena in the direction that we want. So let's start with the first one that I want to talk about quickly is disaster response. So many of you may remember Hurricane Katrina, 2005. And one of the things about it was that 7 months after the hurricane, there was this report that was published which said criticism of FEMA's Katrina response deserved. The Inspector General says much of the criticism is warranted. It took 7 months for us to figure out that something went wrong with FEMA at Katrina. I mean, they were obviously if you remember, some of you may recall that the director was replaced rather summarily, et cetera, but it took us a while to figure out what exactly went wrong, and it took this much time to figure this out. Let's take another challenge that we face, and that is accelerating innovation. If you think about it, a lot of our work gets done in teams these days. And yet, most of us, if I ask you for a show of hands, and if you want to be honest, if I ask you how often have you been on nightmare teams, almost every one of you will raise your hands. If I ask you how often you've been on dream teams, you'll have to think hard about the 1 or 2 instances where that might have happened. So we recognize that a lot of innovation happens in teams, and yet we don't seem to know enough about how these teams come together to work effectively so that they are more likely to be the dream team than the nightmare team. The picture that I have up here is of David Ferrucci. This was an article that he wrote in the New York Times in 2012. David Ferrucci was the person behind the IBM Watson program. So all of you familiar with the IBM Watson? It went on to Jeopardy and was this incredible piece of technology that's able to answer any question that is posed to it by being able to ingest not only Wikipedia, but essentially all the information that was available on the web. Fabulous technology, hugely challenging technology. And yet David Ferrucci, when he wrote the article in the New York Times, says that for all the challenges of the technology, building the team that built Watson was far more challenging than anything in the technology. Because if you think about the ways in which you have a crazy idea, you go to a lot of smart people at IBM who are already busy and have bandwidth challenges, and you try to convince them to join this project, see how lucky you're going to be. And the moment you get one person, so I had a chance to talk to David about this on the phone as well. And he would say things like, well, you get one person, and the question is, the next time you go to someone else, they'll go, well, who else do you have on the team? And based on the kinds of dynamics, you may get a very quick, no, thank you, I don't want to be working with that person. Life is too short. So you have all kinds of different challenges that we face, and we want to do, what is it that we can do to help understand and enable the assembly of better teams. And then the third one, which I'm going to talk about, which is right now very central in the work that I've been doing for the last few months here, are things like global health issues. So this is the tragedy of neonatal mortality. It's pretty well documented that neonatal mortality is a huge problem in the emerging economies, much more so in this country. The first day of a child is the most dangerous day in their life. And that, in fact, the death rates in India, while they are falling in terms of neonatal mortality, is still 10 times higher than it is in the West. So these are real challenges. Now, while this is the bad news, the good news is that there are all kinds of solutions that we have with tools. This is chlorhexidine as an example of this. This is something called as a topical solution where there have been lots of studies that show that if you apply this to the umbilical cord of the child right at birth, the chances of reducing neonatal mortality may be as much as 24% in some studies, or a fifth, 20% in other studies. So they've done RCTs, they've done all kinds of pilot programs. We know that this works. The question is, how do we take this idea that we know works and scale it up across large numbers of districts, states, countries, et cetera? So that's another challenge that we face, where we as social scientists, especially in the area of network science, might have something to contribute to how the scaling up occurs. So it's an inexpensive topical solution. So the real issue is, what can we do to help scale it up from this one district to other places? So my key takeaway for today's talk is that we are in the midst of this perfect storm, where we have, if we can leverage computational thinking, in particular in networks, but not necessarily computational thinking, to understand and address some of these grand societal challenges. And the reason why now is a good time to do it is because we have a confluence of 4 issues that come together in ways that they have never done before. We obviously have a fair amount of understanding of the theories about how we can think about addressing questions and existing questions, as well as emerging socio-technical phenomena. The second is we have access to some methods, especially in the area of networks, which I'm familiar with, but also innovative ways of combining different ensemble of methods, ranging from case-driven, data-driven, ethnographic approaches, along with computational approaches, as a way of being able to study this. I'll talk a little bit more about this in a minute. We can have the methods and the theory, but unless you had the data, there was not very far you could go. We have that now because of the access to digital tracks of data. And an issue that I'm not going to talk about very much today, but which is salient, very salient to those of us who do this kind of work, we have the computational infrastructure to be able to run these analyses. Even as recently as 8 years ago, when I was at Illinois at the National Center for Supercomputing Applications, one of the reasons I was there was to be able to get access to high-performance computing. But even at the time, I can say that some of the analyses that took at the time about 2 weeks to run, we're now able to run in about 8 hours. And that's a huge quantum leap in terms of the kinds of analytics that we can do that we were not able to do previously. So what I want to do is talk a little bit about saying, what is it about theory? What is it about questions we couldn't answer in the past? Well, we couldn't answer these questions in large part because of the data issue that we talked about. It was not possible to collect the data. When I went to grad school and we talked about network analysis, a big network analysis data set would be 100 or a 200 node network. Obviously, I don't need to tell you how large those networks can be today. But that's changed in part because of the new access to digital trace data. David Lazar, who's one of my colleagues at Northeastern University, he has these slides that I love. He says, if you're an astronomer, you collect your data from the Hubble telescope, and it costs $2.5 billion. If you're a particle physicist, you collect your data from the CERN particle accelerator, or the Hadron Collider, and when it works, it costs $1 billion a year to collect that data. On the other hand, if you're a social networks researcher, this is where you get your data from. Now, obviously, this data is not quite as priceless as we learned last year, that there are increasing amounts of price that we are paying in terms of things like the PRISM scandal, if you want to call it that way, or the controversy that we all became acquainted with last year. But all of this to say that one thing that has become possible today is that we now have a whole new way of thinking about social science that we didn't really have until quite recently. David Lazar and a bunch of us wrote this article in Science a few years ago titled Computational Social Science, where our point essentially is that for the first time, in addition to doing case studies and field studies and experiments, or archival studies, we now have the opportunity to be able to study things at scale. And there are several people here at University of Pennsylvania, as well as the Annenberg School in particular, that are at the forefront of doing this kind of computational social science research. So a lot I want to talk about today is that this gives us a new opportunity to be able to address some of the questions that we have not been able to do before. Some of you may have heard of this in the context of big data. I think that big data has some set of challenges. I'm happy to answer questions. I think broad data is far more important than big data. And by that, I mean integrating different kinds of data that we want to bring together. And that's something that's also a very exciting part of this. For example, being able to take data that comes from neural processes, for example, and combining it with data that comes from digital trace and physical location data, allow us to be able to do novel ways of looking at questions which we were not able to do until quite recently. So what are the kinds of things? So Joe mentioned that I direct a research group at Northwestern called the Science of Networks and Communities, SONIC. And so these are some of the areas in which we do this work in the area of applying it in science and engineering, disaster response, entertainment, and health and environment. I'm going to talk about the 3 that I mentioned earlier. The first was disaster response. If you remember, I talked about Katrina. So in that case, some of the questions we thought we couldn't answer is, how do multi-organizational networks emerge in response to a disaster? And by say what we couldn't answer is we could answer it after 7 months, but is there a way in which we could answer it in close to real time? And then how do we then take this understanding of how these multi-organizational networks emerge, and how do we use that to monitor and design interventions to make them more effective? So the first is a more science understanding question. The second is a more of an enabling or an engineering kind of question. The second had to do with accelerating innovation in teams. What are the network factors that influence the assembly of innovative teams? And then how do we design a dream team builder to optimize their assembly? And then finally, scaling up global health solutions. What are the network factors that determine who influences whom and how in order to scale up the adoption of health solutions? And the second, how do we utilize this knowledge to design sequence and strategies that optimize the speed and scope of the scale up at a minimal cost? So I'm going to start very quickly with the first one of these, Hurricane Katrina. You may remember it started out on the 23rd of August. It started in Florida and then went up the Gulf Coast and went into New Orleans, et cetera. One of the things that happens with something like this, which I learned only after the event, was that whenever we have a disaster like this in the United States, every agency, every organization that is involved in it is supposed to publish something called a SITREP, which stands for Situation Report. So this is an open text document that they are supposed to put on the web every day, basically saying, here is what we did today, here is what we are planning to do, here are the people we are coordinating with. An example of that is something that like this. This is not very clear. This is from the Colorado Division of Emergency Management. This was on August 30th. This was their situation report for that particular day. They talk event type, situation, and what they did on that particular day. Now, one of the things that a collaborator of mine, Carter Butts, who's at the University of California, Irvine, what he was doing was he took this data and he had a bunch of undergraduates code this to see which organizations were connecting with which other organizations. And it sounded like a really nice way of being able to do a network analysis, very creative, et cetera. NSF, in the aftermath of Katrina, NSF was basically coming back to some of us who were already funded on related projects and said, why don't you collaborate with each other? So I began a collaboration with Carter where we took the data and instead of having undergraduates coded, we used text analytics. So we used some software that was developed at the National Center for Supercomputing Applications. It was called T2K, Text to Knowledge. And we did automated coding where we looked at this. This was a little before it became much more popular. We did entity extraction. We looked at all the places, people, locations, organizations, and concepts that were involved, and the connections amongst these based upon their appearance together in the report. So this is what the data looked like for the first 2 days of Hurricane Katrina. You'll see there are different colored nodes. The red nodes are organizations. The green nodes are places. The blue nodes are people. This is Governor Jeb Bush in Florida. So you see FEMA is pretty central. Florida is right at the heart of it because first it hit Florida before it went up to New Orleans. You see Texas, Alabama, Louisiana, and New Orleans are actually the margin out here. But then you see that there are interesting insights that you can get. Remember now, this network was generated not by the undergraduates. It was just analyzing the text of the situation reports across all of them. You find that there are a lot of organizations associated with petroleum that were really well connected to each other. It's not so clear from here, but they were really well connected with each other. They had coordinated their responses. On the other hand, up here, near the Salvation Army and the American Red Cross, those are those two, SAL and ARC, there were a bunch of other organizations that were not so well connected, and these were organizations of human shelters, animal shelters, and so on and so forth. So what you do is, instantly by looking at this analytics, you can tell which part of the industry is really well coordinated and which sector in society is not so well coordinated in this context. We could take this and then move it over, and you see that each time you have a different slice, you have different organizations that are moving into the center. And I'm just going to go through these pictures here, but what is interesting as you look at this movement, so this is as we progress day by day in this context, that as you get to the end, we looked and mapped how central both the American Red Cross and the Salvation Army was. And what you find is that, so this is the rank, so a low number means that they were a higher rank, and that you see that initially the American Red Cross was not very central, but by time slice 5, they became very central. On the other hand, FEMA, that was central initially, had begun to drift down, et cetera. So this is the kind of stuff where you can look in real time at the kinds of how multi-organizational networks are forming and be able to not only understand the process of formation, but actually create dashboards that help individuals who are involved in emergency response to be able to make decisions that don't have to wait for 7 months, for example. So what did we learn in this? How did this challenge benefit from computational social science? One, individuals obviously trying to get surveys done. I mean, one question you could have is, why didn't you just go survey these people? Well, in the midst of an emergency, the last thing you want to do is go to the organizations that are involved in saying, could you take 45 minutes to fill my survey on who you connect with, et cetera. So that's clearly not a scalable solution in the event of an emergency. And so even more challenging was to map networks which were not only about organizations, but also with people, places, and concepts so that you can see what are the themes that are developing, et cetera, and the ability to do this in close to real time in order to provide an opportunity for mid-course correction. So I give this again as a modest example of the ways in which we who are interested in computational and network science can not only advance our own understanding of the emergence of interorganizational networks, but also make a difference in these contexts. I'm going to jump to the second one, which is accelerating innovation. What are the factors that influence the assembly of teams? And how do we design a dream team builder then to be able to do this, to make teams more effective? So Joe made reference to a book that, and I made reference to it as well, that I wrote with Peter Manji, in which we looked at the literature on networks and identified the various motivations that people have for connecting with other people in general, but also can apply for why we work on teams. I'm going to ask you to think about all the teams that you have recently joined or not joined, and think about what are the strategies that you use when you have to decide who do you want to team up with. Who do you decide to work with? Why do you decide to work with those people? When you get an invitation from someone, why do you decide to say yes, or why do you decide to say no? What are the criteria that we use when we decide to assemble into teams? One of the things that is interesting is we find that there are lots of different motivations. Sometimes it's self-interest. It's an economic maximization process. I want to work with this person because Bob has deep knowledge about this particular area, and I want to gain advantage from that expertise, and so that's why I want to work with Bob. Or it could be social exchange, which says, I want something that Amy has, and Amy wants something that I have, so we have a social exchange, and that's the reason we may want to work together. The third could be mutual interest, is saying that, God forbid, I don't want anything from Joe, and Joe doesn't want anything from me, but we might want to collaborate together so that we have a better shot of getting something from a third party. So that's the elements of collective action that you have there. So these three are more strategic. On the right-hand side, you have more sort of not so strategic, but things that people do, and that's methods of contagion, which says that, I look around and I see that everyone wants to work on a project with Sandra, and so I decide I should also try to work on a project with Sandra. So it's the imitation, is the contagion mechanism. Or it could be balance. It says that, I'm friends with Joe, and Joe is friends with Emily, so there's a pretty good chance that down the road I'm going to become friends with Emily. Or it could be homophily. It could be that two people have something similar, the birds of a feather idea, so we work together because we have something that we have in common. And theories of proximity, last night some of us were out at dinner, and as much as I was eager to talk to people across the entire table, by virtue of proximity, I was going to talk more to the people who are right across from me. Someone like Barbie, who was across from us, who had much more attention talking to me than somebody who was sitting at the other end of the table, for example. So we have all these mechanisms, and these apply not just to communication, but also in terms of teaming. They're not all necessarily desirable tendencies. So, for example, working with people who are close by to you is not necessarily going to yield to better teams, but that's our natural tendency. Likewise, working for people who are similar to us is not necessarily going to be a desirable outcome. So we talked about this, and in particular, I published an article, sorry, that should say 2013, not 2012 and 2013, I apologize. But this was an article that I published in the Philosophical Transactions of the Royal Society, which I'm particularly pleased for doing because it's the oldest referee journal in the world, and where we talked about ways in which we can think of computational science and web science as a way of helping us understand this process. While there's been a lot, what is interesting about this is that if people are operating based on these tendencies, each of these tendencies has a unique structural signature, by which I mean that if people are operating on the basis of self-interest, there are certain kinds of ties that are more likely to show up and others that are less likely to show up. Likewise, if people are operating on the basis of exchange or balance and so on. What this means is that if I have a noisy network from a group of people by asking you who do you work with, et cetera, I can now conduct a kind of statistical test. Think of it as a statistical MRI that allows me to go and extract the extent to which team-forming behavior in this network is driven, say, 15% based on self-interest, or 20% based on social exchange, or 13% based on proximity, et cetera. So it's a very powerful statistical tool to be able to understand what drives team formation. One of the things that I've been particularly interested in, and I'm working on a book on that topic called Some Assembly Required, is to understand what are the factors that influence how we form teams together. Well, it turns out that while there's a lot of work done on teams and how to make teams more effective, most of it starts with the premise that the team is in place. There's very little research that looks at what happened before the team was formed. How did the team form in the first place? Even though there's pretty good evidence that how the team forms, or what the team consists of, is going to impact the final result. And so I like to say that a lot of my interest in this stops at the point where the team is assembled, which is where a lot of the research on teams starts, which is after the assembly of the team itself. So I'm going to talk very quickly about 4 levels at which the team assembly could be influenced. One is a compositional level. So think of teams as made up of certain individuals. Okay, they have attributes. You know, when you think about it, if I were to ask you and say, well, how do you form a team? Well, if I'm interested in forming a team where I need somebody who has experience in a particular topic, I'm going to go find that person. So those are attributes of the people. The second, though, is the relational level, where you say, I'm also interested in looking at the ties between people, so that I want to know whether these people can get along with each other, you know, whether they trust each other, and so it looked at the relational dynamics. The third, which I'm not going to talk a lot about, is the notion of how you see the team matching with the task. When we look at software development groups, we find that there's some people who really like to work on open source software while others like to work on closed source software. You might say, why? Well, because at university, still the incentive system is to give you credit when you work on closed source software. So there are different reasons why you need to think of the match between the team and the people. And the last one, which I'm quite interested in because I think there's almost no work done on this, is a recognition that people don't belong to just one team. Right? We all belong to multiple teams, and these teams have overlapping members. Yet almost all the research on teams thinks it's very clean and convenient to assume that people belong to just one team and that teams are mutually exclusive, because otherwise you have to deal with all kinds of statistical, hierarchical linear modeling kinds of things that allow you to look at multi-level contaminations and so on and so forth. Well, I think that the point of looking at teams that have overlapping membership and multiple membership is not a bug, it's a feature. And in fact, I'm going to argue that the likelihood of a team assembling together is going to be a function of the number of other teams that they belong to and the overlap amongst those teams. And not only is the assembly of the team more likely, but the success of the assembly of the team is going to be determined by our membership on other teams and the overlap that exists amongst these other teams. So I'm going to go through very quickly some examples of work we've done in this area. A lot of the work that we've done in this area is based on a collaboration that I've had with the other Annenberg School, USC, Dimitri Williams, Scott Poole, my former colleague at Illinois, as was Dimitri actually, and a computer scientist at University of Minnesota who went to high school with me in India. I say this because of the team that has been assembled to come together here. Now, this is a team which looks at virtual worlds. Some of you are familiar with massively multiplayer online games. We've been fortunate over the last 8-9 years now to be able to get access to a lot of different data sets, server-side data as well as survey data on these online games. For those of you who are not familiar with these things, these are typically people who take on characters most of the time, but not all of the time. They can actually work in teams together. And their main goal is to go kill monsters and to go on quests and get plunder, etc. Why is this so interesting to us? Because in many ways, it allows us to study a complete canonical data set of all the activities that went into before they formed these teams together. So here is an example of some 3 or 4 characters who have teamed together to kill that monster that you see up there, etc. So this is data that we collected from Sony Online. EverQuest 2 is the name of the game. And we looked just over the period of about 3 weeks on one server in the game, over 8,000 players playing in over 46,000 groups involved in 9 million combat records. This is the kind of teams data that we just could not even fathom until a few years ago. So what is it that we were interested in finding? We wanted to see the extent to which diversity on the team was likely to impact their performance, and the extent to which group members' cosmopolitan level, that is, if a group had people who played with a lot of other groups and a lot of other people, were those groups going to be more successful than groups where people just played with the same other people, et cetera. The nice thing about studying this process is that in these games, you have very clear performance measures. We have the number of points they gain, NPCs kill, which is the number of monsters. It's called the non-player characters. So these are computer-generated monsters they kill, the amount they gain in level, and a negative measure of performance, which is the number of times they get killed. Because in this game, you can get killed, and then you pay a penalty, and after a short period of time, you can be born again. But these are measures of performance that are quite interesting in this case. So we have control variables, and what we found is quite interesting, that diversity in the teams, and remember, we had 46,000 teams to look at. If the team was diverse, and what do we mean by diversity? We had different characters. We had some characters who are fighters, offensive players. We have some characters who are scouts. These are defensive players. There's some characters who are mages. These are magicians who heal you. And then finally, we have who cast a spell, and then we have priests who heal you. So these are the four main characters in this game. And we find that if your team was made up of people from all these characters, you were more likely to gain points, kill monsters, gain level, but not particularly helpful in predicting how often you get killed. On the other hand, you look at members being cosmopolitan, that is, members who were on teams where you played with people from a lot of other different groups, that they didn't help much with positive measures of performance, but they helped reduce the number of times you get killed. So there's something about your group having access to other groups who had access to other groups that may not help you with your productive, positive performance, but helps protect you against negative performance. So again, illustrative of the kinds of things that we may want to be looking at here. I want to go next to the relational level and look at how prior relationships might actually help explain whether a team comes together and whether that team is successful. So in this case, we take a somewhat serious difference. I know some people have problems with me spending so much time studying online games. I think that I'm happy in Q&A to defend that statement, but in the interest of this particular case, I'm going to say we took a somewhat more serious data set. So here we looked at over 1,000 grant proposals that were submitted to the National Science Foundation. Some would say that's not really any different from massively multiplayer online games, but this was an interesting data set that we had because it was a data set that included both funded and unfunded proposals. Most of the time we don't have access to unfunded proposals, but I was in an advisory subcommittee for a short period of time. I was on the advisory subcommittee in NSF, and for a short period of time they gave us access to both funded and unfunded projects. So it was over two interdisciplinary programs, 3-year period, over 2,000 PIs and co-PIs who were involved in this. And so we asked two questions: who submits proposals? And we basically get two answers in terms of prior relationships. People who have co-authored with one another are in fact more likely to submit a proposal, not surprising. So this, of course, looks again at a large data set because we have access to Thomson Reuters, who have given us at Northwestern a copy of the entire bibliometric database that we are then able to query against to look at who amongst these people had co-authored. We also asked the question, are people who cite each other more likely to submit proposals? And the answer was absolutely, because if two people cite each other, it means they're more likely to know one another's work, and that's going to make them more likely to submit a proposal. We changed the question from who submits proposals to who submits successful proposals. And now things get a little interesting. It turns out that if two co-authors, previously co-authors, submit a proposal, they're in fact more likely to submit a proposal that is successful. But that if two people who have cited each other submit a proposal, they're actually less likely to have a successful proposal, to get funded. And you might ask the question, this seems counterintuitive. We found this, by the way, I'm reporting on one data set, but this is a consistent finding we find across many different data sets, including some NIH proposals that we also studied in a different context. And we reached the conclusion that if two people don't cite each other, that's because these two people are citing different bodies of literature. And the likelihood of creating something innovative is increased when people come from different intellectual communities and are able to bring together something that is then likely to be successfully awarded as a proposal. So another example for the same area, coming back to our online games, so we go back to the monsters example. Here we looked at, again, team assembly in online environments. Here we looked at a different time span, a 1-week data set of who comes together in teams, and we found some interesting results. So first of all, the people who play this game have a spread, a population spread that's very similar to the US. In fact, if you look at the people who play this game and look at the centroid of their population, it almost overlaps exactly with the centroid of the US population, which I think is somewhere in Kansas, if I'm not mistaken. So the spread is actually quite representative of the US Census population data. Here are 4 networks that come out of that. The one on the top left is who plays with whom. The black are the male, the red are the females. So what you find for the most part is people play with other people who play with other people who play with other people. In network parlance, this is referred to as creating one giant component where everyone is X degrees of separation from everyone else. But you also see on the top that there are lots of people who don't play with anyone other than 2 or 3 other people. And the question is, who are these people? Your first instinct may be, well, they're newcomers to the game, and that's why they haven't connected with everyone else. It turns out that because we also have an ethnographer on the team, Tracy Kennedy, who was trained with Barry Wellman's group, one of the things that we were able to understand in the game is that, in fact, that's not the case. A lot of people go online and play with 2 or 3 other people, namely their family members and significant others. And that's it. They don't play with anyone else in the game. And so that's part of what we noticed in terms of how these teams form. I'm going to very quickly touch on something else, and then I can bookmark it. This particular one is trade. That is, who do you trade with? So that's a different kind of network. Who do you buy things from? In the game, you can actually buy wardrobes, and you can buy weapons and all kinds of things from other people if you're rich enough in the game. Most of the trade is legal, and this is an example of what that trade network looks like. There's also illegal trade in these games. It's called gold farming. And the idea of illegal trade within this game is typically Chinese who get up early in the morning and go to bars, and they start playing the game. And they take a character at 0 level, and they play the character all day till they move the character to a high-level character. And then they sell that character to some lazy Westerner who doesn't have the time to play the game but has the money to buy the character. Now, this is something that the Chinese seem to think is a perfectly legitimate way of doing things, and they are bolstered by a World Bank report that came out 3 years ago, looking at the economy, the labor economy in China, and recommending people play this game because the wages offered through this game is higher than the minimum wages in China. But it's a source of a lot of discomfort to companies like Sony, where Sony is afraid that they lose their legitimate players because their legitimate players don't want to play with these imposters who have got level 70 characters and don't really know the game. A former student of mine, Brian Keegan, who's now at Northeastern and at David Lazar's lab, looked at the analysis and found that you can actually identify these are called gold farmers, that you can identify gold farmers by looking at the ways in which they have network patterns of trading with other people. They don't simply create this and sell it to a stranger because that makes it easy for Sony to shut down their accounts. Instead, he found that they have structural signatures that are actually very similar to the networks that exist among drug traffickers, data that was collected by Morcelli in Canada by looking at court records of who was arrested with whom for drug trafficking. So there's some really interesting generalizations across it. So that was a digression. It's not about teams. But I'm going to touch last year on ecosystem, and then I'll move on to the scaling health example. So the ecosystem level, if you recall, said that people don't work in teams, in a single team. They all belong to multiple teams. And we wanted to see the extent to which the fact that you belong to teams that have people who belong to other teams that have people who belong to other teams, how is that going to impact what you do? So these are people who belong to different teams, A, B, C, and D, and you want to see the extent to which those other teams are going to influence whether they form a team by themselves based upon the other teams. So we asked ourselves, so in this case, we again looked at proposal data, but this was data from NIH. And we looked at people who were putting in proposals to do clinical and translational science. So here we looked at 100 research proposal teams. And you think, oh, this is not a lot. But for each proposal, we generated a data set. We looked at each proposal. We looked at all the articles that these people had co-authored with other people. And then we looked at all the articles that those people had co-authored with other people, and then one step farther. So we built an ecosystem of over thousands, in some cases 20,000, 30,000 articles around a single proposal. And we wanted to see the team interlock, the amount of overlap amongst these teams that wrote articles, to see the extent to which there was connectivity or team interlocks or overlap in teams amongst the people who were the co-authors and the co-authors of the co-authors and so on of the proposal. And what did we find? We found that, first of all, how does the established of one strong team impact new people proposing teams in this area? And we find that If in fact there is already one strong team that is doing a lot of work in this area, that suppresses a lot of other people from submitting proposals because there clearly is a dominant person in this ecosystem that exists, or a dominant team that exists. The second was, how does the coherence of the intellectual neighborhood? So what do I mean by that? If there's a lot of overlap amongst these teams across, that's actually more likely to propel you to submit a proposal because this area has some legitimacy. These are people who talk to each other, they work with each other. So this area has now developed some degree of coherence, and that's going to propel you to submit a proposal. However, if you want to have a successful proposal, you want to have overall you want to have overlap amongst the teams, some amount of overlap, but you don't want to have overlap in your immediate neighborhood. So that if you're putting a team together, you're better off having people who work with other teams that don't work with each other. So that allows you, again, to bring in the new ideas into this particular context. So again, taking these ideas, what we've been spending a lot of time is trying to see how we can develop technologies, or in some cases, like have a Moneyball to help assemble the next Watson team. Some of you are familiar with Moneyball, the movie, in terms of being able to look at this assembly. I'm not going to go through this, but there are lots of different demos and tools and technologies that we've developed that allow us to be able to study, enable, as well as understand research networking amongst faculty members who want to put together. We have a project right now at Northwestern where we are using this to help faculty at Northwestern connect with other faculty to be able to form teams. We also have something called the My Dream Team Builder, which is to have students in classes be able to form teams based on connections into form teams and then study how they form teams and how that impacts their grades. Okay. So obviously this benefited by looking at behavioral network data, citation data, using computationally intense algorithms to confirm these hypotheses, and then finally developing the kinds of tools to assist individuals with team assembly. The last thing I'm going to talk about is the global health solution. So what are the network factors that help determine who influences whom and how? I'm going to rush through these slides in the interest of time here. I'm going to say that the initial assumption was that scaling up of family health solutions from innovation districts, that is places where it has worked, to scale up districts where it hasn't yet been adopted, depends on social influence strategies, central touch points, and media channels. Social influence strategies refers to the how to influence. How do you influence somebody else? The central touch points refers to who to influence, who are the central people to influence, et cetera. And then, of course, the media channels. Again, in the interest of time, I'm just going to talk very briefly through some of these slides. Right now, we're in the midst of doing a study that involves 16,000 people involved in a network survey. This is now a project, a third project. We finished a pilot project last year where we did this with 1,200 people. And on the basis of that, I learned something very interesting. So here were some of the initial districts where some innovations had been put in place, and we wanted to move it from the light gray districts to the dark gray districts. These are districts in the state of Bihar in India. And one of the things that I learned was we did a network analysis of which government officials and which NGO family health workers talk to and get advice from others. And when we took these results to the Gates Foundation and to the India Country Office, and they looked at it and said, look how actionable networks is. You can see exactly if you want to move it from this district, here is the person you need to talk to, and have this person talk to this woman in this other district who's influential, and they're going to be able to do it. Very much along in the spirit of, some of you may be familiar of Rogers and Kincaid's work on looking at how diffusion of innovation happens in these contexts. And I was rather pleased with it, and they pointed out to me, and they looked at me and says, well, this is interesting, and this is very helpful, but you're telling me who should talk to whom, but what should this person say to the other person? And as a social networks researcher, this is not something I had spent a lot of time thinking about. And so I'm going to jump to the part that I think would be, I want to end with here in the interest of time, and that is for the first time, about a year ago, they got me thinking about the fact that, this is what I told them actually when they said this to me. I paused for a minute and I said, so you're telling me that what I've done is given you a Match.com, where I've said that if you log in, I'm telling you who you should go on a date with, and you're coming back and saying, thank you, but that's not enough. You need to tell me what to do on the date. And so part of what it got me thinking about was exactly this notion of social influence and recognizing that there are two disparate bodies of literature in social influence. Trained as I was in social networks for the most part, there's a whole body of very impressive literature in social influence, but the entire focus is on finding the right connectors and the right people who need to connect to one another, the who to influence. And then in social psychology, there's a vast body of literature that doesn't focus on the who to influence, but focuses much more on the how to influence, the social influence strategies broadly. A lot of this has been popularized in communication under persuasion research and in social psychology. Bob Cialdini wrote a lot of popularized books on this particular topic. One was called, I think, 6 Degrees of Influence. And it is mostly saying that we are motivated, that when we change, we're motivated either by the desire to be, or the need to be liked by other people, or the motivation or the need to be right about something. And under that, they have a lot of categories. And so what we did is we just published this. Well, I shouldn't say we just published this article. So this is an article that's going to appear in PNAS. It's going to come online on the 15th of September. And we titled it, Integrating Social Networks and Human Social Motives to Achieve Social Influence at Scale. And it's about the Gates project that I was just mentioning to you about. So one slide from that is to say that this one is the who to influence, and this one is the how to influence. So you can have people who are the right people who you might want to choose for making an influence. And then you look at the kinds of messages that need to be sent to them. Different people, based upon whether they are more motivated by the need to be liked or the need to be right, are going to be more receptive to different kinds of messages. And one of the interesting things, and I think Joe alluded to this in his introduction, is that at this late stage in my life, I think that I'm coming to terms with the fact that we need to be able to really integrate the who to influence with the how to influence in ways that sadly, that scholarship doesn't really exist. And I think both will benefit greatly from doing this. So again, how did this challenge benefit from computational social science? Obviously, we're using computational modeling as a way of seeing how to sequence the spread of these things across the different districts. Providing decision support, we're creating a dashboard to help individuals see not only who they should connect, but what messaging strategies are more likely to be successful, and then revise the sequencing based on that. So what I've done today is talked about 3 grand societal challenges and modest attempts and small examples of how we as a field can help address issues within this area from a communication, computational, and network point of view. The key takeaways that I said, which makes this an interesting time to do this, is because we have a vast amount of theory already built and the potential for building new theory. We have some methods that I illustrated today, some ensemble methods that allow you to be able to look at the different ways in which these things come together, data development, access to data, as well as computational infrastructure that we need this. So I'm going to go ahead and stop with that. Stay mostly on time and have time for questions. Thank you.